Hey everyone, ever thought about what would happen if you took two different geometric moves, like a slide and a flip, and just kind of smashed them together? Could you make one single super powerful new rule? Well, the answer is yes, you absolutely can, and that's exactly what we're going to dig into today. Let's jump right in.
I know, what's with the goose? But seriously, take a look at these tracks in the snow. Each footprint is a slide and then a flip of the one before it. This sequence, a translation followed by a reflection, has a really cool name, a glide reflection. It's a perfect real-world example of what we're talking about, combining transformations into something new. And that whole process is called a composition.
So here's our game plan. First, we'll nail down what a composition actually is. Then, we'll do a quick review of our basic moves. After that, we'll dive into a bunch of examples, putting it all together. And we'll wrap up with the one key takeaway that makes all of this click. All right, first things first, let's get the main idea down. What are we really doing when we talk about making a composition of transformations? You know what? It's actually super simple. A composition is just a sequence of transformations. That's it. It means you do one move, and then you do another move to the result of that first one. Think of it like a 1-2 punch. First one thing, then the next. Okay, so before we can start building these new rules, we gotta make sure we've got our tools ready. We're about to do a real quick run-through of the algebraic rules for our basic transformations. These are going to be our best friends for the rest of this explainer. All right, here's our cheat sheet. We've got our rule for translations, just adding to x and y. Then our three big reflections, a couple of the most common rotations, and of course dilation for making things bigger or smaller. We are going to be pulling directly from this list, so knowing these is really going to help you fly through these problems. And here we go. This is the main event. We've got our definition, we've got our toolkit of rules. Now let's walk through the problems from the worksheet and build these new combined rules for each one step by step. First up, translate right 4 and up 2. Okay, so from our toolkit, that rule is x plus 4, y plus 2. Got it. Now for the magic part. We apply the second rule, the reflection over y equals x, to that result. The reflection rule is easy, it just swaps the coordinates. So the entire y plus 2 piece becomes our new x, and the entire x plus 4 becomes our new y. And boom, there it is, our final rule. Okay, let's try a rotation and a dilation. Step 1, rotate 90 degrees counterclockwise. The rule for that is negative y comma x. Step 2, we're going to dilate that result by a factor of 3. The rule for dilation is just to multiply each coordinate by that number. So negative y becomes 3 negative y, and x becomes 3x, which gives us our nice, clean, final rule, negative 3y comma 3x. Now, this one has a little trap you've got to watch out for. First, we translate, which gives us x minus 4, y minus 2. Simple enough. Then, we reflect over the y-axis. Now, that rule makes the entire x-coordinate negative, so our x minus 4 becomes negative x minus 4. The crucial move here is to distribute that negative sign to both things inside the parentheses. That's how we get to our final rule of negative x plus 4, y minus 2. Seriously, watch out for that distribution. It's such a common mistake. Let's do another rotation and dilation, but this time with a fraction. A 90-degree clockwise rotation gives us y comma negative x. Then we dilate that by 1/3. It works just like before, we just multiply each part by the scale factor. So we get y over 3 and negative x over 3. See? The process is exactly the same. Once you get the pattern down, it really starts to click. As we're getting into all this algebra, it's pretty helpful to take a step back and remember what's actually going on. Each of these rules we're making is just a set of instructions. It tells you how to take any point, x, y, on this grid and move it to a new spot. We're basically creating a shortcut to get from the starting point to the final destination in one single jump. Okay, back at it. We translate to get x plus 4, y minus 2. But this time, we reflect over the x-axis, which means we make the entire y-coordinate negative. So the y minus 2 part becomes negative y minus 2. And just like we saw before, you have to distribute that negative. That gets us our final simplified rule, x plus 4, negative y plus 2. It's the exact same trap as before, just on the other coordinate this time. Here's a nice direct one. A 180-degree rotation gives us negative x, negative y. Then we dilate by a factor of 2. All we do is multiply our new x and y by 2, which gives us negative 2x, negative 2y. Pretty straightforward and clean, right? It's kind of nice when they work out that simply. Let's do one more translation and reflection over y equals x, just to really lock in that pattern from the first problem. Okay, first, translate left 4 and up 2. That gives us x minus 4, comma, y plus 2. Then we apply that reflection rule. Just swap the coordinates. Our new point is simply y plus 2, comma, x minus 4. Same process, just different numbers. And for our last example, let's do one more 180-degree rotation followed by a dilation. The rotation gives us negative x, negative y. Dilating by a half just means multiplying by 1/2, which is really the same as dividing by 2. So our final rule is negative x over 2, negative y over 2. And with that, we're through all the examples. Whew, we just powered through 8 different combinations. So let's boil it all down. What is the one single most important process here? What's the master key that's going to unlock all of these problems for you? This right here is the whole game. It's a 4-step process. First, you grab the rule for your first move. Then, you grab the rule for your second move. Now here's the secret sauce. You take the result of that first rule and you substitute it into the x and y of the second rule. Clean it up, simplify it, and bam, you've created your brand new combined rule. That's the method every single time. So I'm going to leave you with a question to chew on. We did all of these examples in a very specific order. But does that order actually matter? What would happen if you took one of the problems, like that first one we did, and you flipped the steps? What if you reflected over y equals x first and then did the translation? Would you get the same final rule? Give it a try. The answer might just change how you look at these geometric puzzles.